Hi Chase, and welcome to another video lesson. What I think we're going to do today is run through some of the exercises in your book for complex numbers, because I know you've been battling with them. So I'm going to go do the mixed questions section of your textbook, and I'm going to see how many I can get through in the video, so that you've got something really nice to review from for your exam. I think that'll be quite useful, and maybe if I get time I'll do another one on section 4, which is trig. But at the moment we're going to start with complex numbers. Let's get that complex numbers. Exercise 3.8 from your textbook, which is the mixed questions. So I'm going to go through these fairly quickly, and if you don't understand a step, just pause and re-listen to my explanation, but I'm going to try to get through as many of these as possible. So let's start here with number one. Number one, given that Z1 equals minus 3 plus J2 and Z2 equals 4 minus J3 and Z3 equals 5 plus J12. Okay? The question is, calculate a Z1 plus Z2 plus Z3. Now remember, I said with complex numbers, all we're going to do is add them as if it was algebra and the J was a variable. Okay? Oh, my apologies. It's not plus Z3, it's minus Z3. Okay, so let's start. Z1 is minus 3 plus J2 plus, I'm going to put these in brackets for clarity, Z2 is 4 minus J3 minus Z3 is 5 plus J12. Okay, so let's start adding. Or let's first multiply out. So just multiply that negative into the bracket. So we're left with minus 3 plus J2 plus 4 minus J3. Multiply the negative into the bracket. Minus 5 minus J12. Okay? So let's start by adding all of the real parts, which is that minus 3 plus 4 minus 5. So we add those together. And minus 3 plus 4 is 1. Minus 5 is negative 4. Okay, then we're going to add up the imaginary parts, which are plus J2, minus J3, and minus J12. So J2 minus J3 is minus J1. Minus J12 is minus J13. Okay, and there's your answer. Alright, let's move on to number B. Z1 times Z2. Okay. So, for Z1 times Z2, what we've got is minus 3 plus J2 times 4 minus J3. Now remember, we said multiplication of complex numbers is easier in polar form. Okay, but for now I'm going to do it in rectangular form because I have a suspicion that that's actually what they want. So let's quickly do this multiplication, and once again we just do FOIL, just normal FOIL. So let's start. We've got firsts, which is minus 3 times 4, so that's minus 12. Okay, then outers is minus 3 times minus J3, which is equal to minus 3 times 3 is 9, and carry the Well, minus 3 times minus 3 is plus 9, and carry the j, so plus 9j. Okay, then we've got our inners, wrong color, inners, which is j2 times 4, which is plus 8, or plus j8. Okay, and then let's see if I've got another color here. No. Okay, let me quickly grab another color there so that we can make this a little bit easier. Let's go with a nice little. Okay, there we've got another color. Okay, and that we can store in F6. No. Alright, let me try that again. F6, we're gonna make it a little funny shade of blue. Okay, let's try that again. Okay, so now we've got our lasts, which is j2 times minus j3. Okay, so positive times a negative is a negative. 2 times 3 is, well, let's do the j's. J times j is j squared, which is minus 1, times 2 times 3 is 6. Okay, and then let's just simplify that a little bit. So we've got minus 12 plus j9 plus j8 plus 6 plus, these colors are killing me. Okay, I'm going to do it in white. Plus 6. Okay, now we just add our real and imaginary parts. So we're going to add our real parts and our imaginary parts. Okay, so starting with the real parts, minus 12 plus 6 is minus 6, and j9 plus j8 is plus j17. Okay, and there we have our answer for number B. Okay, let's move on to question C, 1C. Okay, alright, and C says, given those numbers, one color again, C says, given those numbers, calculate Z3 over Z2. Okay, Z3 over Z2 is equal to 5 plus 12 J12 over 4 minus J3. Now, once again, this would be easier in polar form. Okay, so you know what, I think that let me just check in the rest of the exercise if there's more options. Yeah. Okay, yeah. Right now, we're going to do this one in polar form. Okay, so we first got to convert to polar form. And how do we convert to polar form? Remember that our complex numbers are in rectangular form, which is in the form a plus jb. But now we're going to convert to the form r angle theta. Okay, so we need to know r and theta to get into polar form. So r equals square root of a squared plus b squared, and theta equals tan inverse of b over a. Okay, so this would be a good point to grab your calculator. So let's first do it for the top, the numerator. So which is Z3. So I'm going to call it R3 and theta 3. So R3 equals the square root of A is 5. So we've got 5 squared. And B here is 12. So plus 12 squared. And theta 3 is arctan B over A, where B is 12, according to our general form, and A is 5. So arctan or tan inverse b over a, which is 12 over 5. And we're just going to pop those values into our calculator quickly. The square root of 5 squared plus 12 squared is 13. And tan inverse of 12 over 5 is going to give us 67 degrees. 67,38 degrees. Now we're going to do the same for R2 and theta 2. I'm not going to rewrite the formulas. R2 is the square root of a squared plus b squared, which is 4 squared plus b is minus 3 squared. Just note that, minus 3. Because what goes with the j? Minus 3. Okay, so that's our imaginary part, is minus 3. So we've got 4 squared plus minus 3 squared, and theta 2 is tan inverse of b over a, and once again b is minus 3 over 4. Okay, and those are equal to, let's calculate it, square root of 4 squared plus minus 3 squared is 5, and arctan of minus 3 over 4 minus 3 over 4 is negative 36,87 degrees. Okay, so now that we've got R3 theta 3 and R2 theta 2, we can just rewrite this equation as R3 angle theta 3 over R2 angle theta 2, which is R3 is 13 angle 67,38 degrees, and that's all over. R2 is 5 angle negative 36,87 degrees. Don't forget the degrees. Okay, and then from De Moivre's theorems, we know that, okay, so from De Moivre's theorems, I'm going to write it here in the top right, R1 or Z1 over Z2 in polar form is equal to R1 over R2 angle theta 1 minus theta 2. So if we apply that here, this is equal to 13 over 5 angle 67,38 degrees minus negative 36,87 degrees. Okay, which is equal to 13 over 5 is 2.6, so that's 2,6 angle 67.38 plus 36.87 is angle 104.25 degrees. And there you go. That's your answer. Okay. Let's move on to question 2. Okay, let me grab some space here for us. Oh, running out of space. Alright, we'll open a new background here. Okay. So, question 2, let me just check that I'm all the way at the top left. That should be. Looks like it. Okay. Question 2 says, question 2. Determine the complex roots of x squared plus 6x plus 13 equals 0. So what they're basically saying is factorize this equation, because that's what you do to find the roots. You factorize. And how do we factorize? Well, we could try the trinomial approach, but it's not going to work because they're already telling us that it has complex roots. So the trinomial approach won't work. So how are we going to do it? We're going to use the quadratic equation, which is x1 or 2 equals negative b plus or minus the square root of b squared minus 4ac over 2a. And remember, this equation here at the top is in the form of ax squared plus bx plus c equals 0. And this is the general form of a polynomial of the second order. Okay, so let's plop the values into the formula and we're going to get out our roots. So negative b is 6, so minus 6 plus or minus the square root of b squared, which is, b is, once again, 6 squared minus 4, what is a? Look at the form, a is in front of x squared. What's the coefficient or the number in front of x squared? It is 1. Okay, and c is, look at the form, c is 13. Okay, over 2a, and we already saw that a is 1. Okay, so this is equal to minus 3 plus or minus the square root of 36 minus 4 times 13. 4 times 13 is 52 over 2. You'll notice I just divided this first number here by 2. Okay, so that is equal to minus 3 plus or minus the square root of 36 minus 52 is, let's just calculate that, minus 16 over 2. Now, I'm just going to carry on up here. Okay, how do we get it into complex form? So, minus 3 plus or minus, then we start factorizing. Oh, yes, factorizing. Okay, we've got the square root of minus 1 times 16 over 2. So that's minus 3 plus or minus the square root of let's write it out like this. Square root minus 1, square root of 16 all over 2, which is equal to minus 3 plus or minus, what's the square root of negative 1? It's j. The square root of 16 is 4 over 2, which is then equal to minus 3 plus or minus j4 over 2 is j2. Okay, so we've got minus 3 plus j2, and those are the roots. So, because the formula says x1, 2 equals that. So, our roots are going to be x equals minus 3 plus j2, or x equals minus 3 minus j2. And there you go. You've got your complex roots. You could probably have left it in this format. I just wrote it out like that. These two are exactly equivalent. It's saying the same thing. Okay. So that's question 2 done and dusted. Let's go on to question 3. Okay. Question 3 says, given that Z1 equals 3 plus J2, Z2 equals minus 6 minus J, and Z3 equals minus 2 plus 4i, minus 2 plus J4. Okay, calculate Z1 times Z2 plus Z3. Now, what would probably be the fastest. Well, this whole equation you could just pop into your calculator and solve, or you could just convert Z1 and Z2 into polar form in order to do the multiplication. Because remember, multiplication is easier in polar form, and addition and subtraction, so multiplication and division are easier in polar form. Addition and subtraction, you want rectangular form. But you can still do the multiplication or the division for that matter in rectangular form if you really want to. But you can't do addition and subtraction in polar form. So I'm going to do it just in rectangular form. Keep it all simple. And yeah, so let's get cracking. So let's start off with Z1, which is 3 plus J2. Okay, and that is multiplied by Z2, which is minus 6 minus J. And then we've got Z3 plus Z3. Okay, plus Z3, which is plus minus 2 plus J4. Okay, so the first thing we're going to do, according to BODMAS, we do the multiplication of these two brackets first, and then we add this afterwards. So let's do that. Okay, so we're just going to do normal FOIL once again. So first is 3 times negative 6, which is minus 18. Then we're going to do our outers, which is 3 times minus j, which gives minus j3. Then we're going to do our inners, which is j2 times negative 6, which is negative 12j. Okay, and then we're going to do our lasts, which is going to be, we've got positive times a negative, which gives a negative. Then we've got j squared. J times j is j squared. And then 2 times 1, which is 2. Okay? And let's carry on and simplify that a bit. Minus 18 minus j3 minus 12j. And here we've got negative times j squared, which is negative 1. So you've got negative 1 times negative 1, which is positive 1. So that gives plus 2. Okay? Now we're going to add our real and our imaginary parts as usual. So let's add the real parts, which is minus 18 plus 2. Minus 18 plus 2 is equal to minus 16. Then we're going to add our imaginary parts, which are minus j3 and minus 12j, which gives minus j15. Now, I made a big mistake here, and I don't know if you saw it, but I forgot in the equation to leave this piece in. I just did the multiplication, I didn't carry this piece, which would have been stupid. So, don't forget that. It's plus minus 2 plus j4. We're just going to, okay, minus 2 plus j4. Okay, so now we've also got here minus 2 plus j4. Let's finish adding the real and imaginary parts. Minus 16 minus 2 is minus 18, and minus j15 plus j4 is minus j11. There you go. That's your answer. Yeah, that's it. Very simple. Okay, let's move on to question 4. Okay, so question 4 says, express the following in a plus jb form or rectangular form. And the number that they want you to express in a plus jb form is 2 cos pi over 4 plus j sine pi over 4 cubed. Okay, so now we've got this, and it looks a little bit intimidating, but what you need to realize is that this is just made a mistake. This 2 goes inside the brackets. I'm sorry about that. So the 2 actually goes there, and then they had another bracket inside there. So let me just write that out again. What it works out to is the cube belongs to the 2 and to this whole piece here, the cos and sine piece. So it's 2 cubed cos pi over 4 plus j sine pi over 4 all cubed. Okay, so let's start off with the easy part. 2 cubed is 8. Actually, no. Let's leave it like this for now. Okay. What you need to realize is that this is just written in the form Z equals R cis theta. Because that is R cos theta plus J sine theta. Okay, so there's nothing to worry about. And remember that cis theta is exactly the same as, so writing R cis theta is the same as writing R angle theta. Okay, so we're going to express it like that in polar form. So what this expression actually translates to is it's R angle. What is the angle? Look here. Okay, cos theta plus j sine theta. So cos pi over 4 plus j sine pi over 4. So that is in the form R angle theta cubed, which is R is 2 angle pi over 4 cubed. Okay, so now we've written it in a form where it looks far less intimidating, but we still haven't expressed in a plus jb form, because we first need to cube this whole bracket out. So that is equal to 2 angle pi over 4 times 2 angle pi over 4 times 2 angle pi over 4. Okay, so we're just multiplying our polar form complex numbers. And remember what de Moivre's theorem says. De Moivre says that R1 angle theta 1 multiplied by R2 angle theta 2 is equal to R1 R2 angle theta 1 plus theta 2. Okay, so let's do that. So we multiply these two out, and then we're going to multiply the result of that with that one. So according to de Moivre's theorem, like here on the right, we've got 4, which is 2 times 2, angle pi over 4 plus pi over 4. And pi over 4 plus pi over 4 is pi over 2. If you don't know how to work that out, just do pi over 4 plus pi over 4 in your calculator, but it's 2 pi over 4 and therefore pi over 2. Okay, so we've multiplied out the first two brackets, and then we've got again 2 angle pi over 4. Okay, so again we use de Moivre's theorem, which says multiply the r's, so 4 times 2 is 8, then add the angles, pi over 2 plus pi over 4. Okay, that is equal to 8 angle pi over 2 plus pi over 4 is 3 pi over 4. Once again, you can do that addition on your calculator if you're not sure how I got there. It's just normal addition of fractions. Okay, and there's your answer to number 4. Done. Okay. We've got a little bit more space here. Great. So, question 5. Let's tackle it. Question 5 says, determine the value of z in polar form and then convert your angle to rectangular form. So, determine z in polar form and convert to rectangular form. Okay, and z is expressed as 4 angle 30 times 4 angle 40 degrees, don't forget your degrees, over 6 angle 20 degrees. Okay, all to the power of 5. So before we worry about the power, let's just simplify this thing inside of the brackets. And once again, we're going to use De Moivre's theorem. De Moivre, which says that R1 angle theta 1 times R2 angle theta 2 is equal to R1 R2 angle theta 1 plus theta 2, and also De Moivre's division rule, which says R1 angle theta 1 over R2 angle theta 2 is equal to R1 over R2 angle theta 1 minus theta 2. Okay, there's also another version of De Moivre's law, which we're going to use when it comes to taking powers. And you'll see that it's actually derived from this rule. I'm not going to explain why. If you want to know, you can ask me in person. But another version of De Moivre's multiplication rule says that actually the De Moivre's rule is in your book for powers, so don't worry about it. But basically what it says is that R angle theta to the power of n is equal to R to the n angle R to the n angle n theta. So take R to the power of n, angle of n times theta. Okay, so let's do that. Okay, first thing we're going to do is simplify this inside piece by first multiplying out the top. Okay, we're going to multiply that out. Then we're going to do the division. Then we're going to take it to the 5th power. So, using the first law that I wrote here, we've got R1 angle theta 1 times R2 angle theta 2 equals R1 R2, which is 4 times 4. So that is 16 angle theta 1 plus theta 2, which is 30 plus 40, which is 70 degrees, over 6 angle 20 degrees. Okay, so now we're going to use the second rule of De Moivre, which says R1 angle theta 1 over R2 angle theta 2 equals R1 over R2, which is 16 over 6. Oh, don't forget to carry your power. 16 over 6 angle theta 1 minus theta 2, which is 70 minus 20. 70 minus 20. Okay, which is equal to 16 divided by 6 is 2,67. Angle 70 minus 20 is 50 degrees. Okay, and once again, I keep doing it. Don't forget to carry your power of 5. That never disappeared. Okay, now we've just got to take this number inside the brackets to the 5th power. Okay, so we're going to use De Moivre's last rule, which says R angle theta to the n, which is what we have, R angle theta to the n is equal to R to the n So that's equal to 2,67 to the power 5 angle n theta, which is 5 times 50. So 5 times 50, okay, which is equal to 2,6, no, let's say 2.67 to the power 5, 2.67 to the calculator, to the power 5 is 135,69 angle 5 times 50 is 250 angle 250 degrees. Now, just as an aside, you'll note that, so here's our complex plane, other way around, imaginary and real. Okay, so let's draw this number out. 135 angle 250. 250 lies somewhere here. Okay. So you'll note that this angle here is 360 minus 250 is equal to, and this angle is negative because we're measuring it in the clockwise direction. So negative 360 minus 250 is too lazy to do it in my head right now. 360 minus 250 is 110, so that's minus 110 degrees. So we can also express this number as 135,69 angle minus 110 degrees. Okay, and there you have it. There's your answer to question 5. Almost missed it. They said, determine the value of z in polar form and then convert to the rectangular form. Okay, we've got our answer in polar form, not in rectangular. So let's quickly get it into rectangular form. So our value is, I'm going to have to open a new page. So 135.69 angle 250. Let's open a clean page now. So 135.69 angle 250 degrees. And how do we convert polar form to rectangular form? So now we're in the form r angle theta, and we want to go to the form a plus jb. Okay, so we know that a is equal to r cos theta and b is r sine theta. So let's do the conversion. A equals r cos theta equals, what is r? According to the form, r is 135,69 theta, cos of theta, according to the form, theta is 250 degrees. Okay, and you pop that into your calculator quickly to get the value of A. 135.69 cos of 250 degrees is minus 46,41, and B is equal to R sine of theta is equal to 135,69 sine of 250 degrees. Pop that into your calculator and it will tell you that B is negative 127,51. Okay, so now we just got to write it out. So Z equals A plus JB minus 46,41 plus, no, it's plus JB, but you'll note that B here is negative, so it's going to be minus J 127,51. Okay, note that negative. The form states it's plus, but B is negative, so it's a negative in front of the J. And there's your answer. to question 5. Alright, let me open a new one for question 6. Okay, and we'll get into question 6 in a minute. Okay, question 6. Another one. Okay, I'm going to go through this one extra fast because I've shown you how to do it. Calculate the complex roots of x squared minus 8x plus 41 equals 0. And remember that's in the form ax squared plus bx plus c equals 0. Okay, so once again we're factorizing, so we're going to use the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, so we're just going to pop in our values and we're going to get out our complex roots. Nice and easy. So minus b is negative 8 plus or minus the square root of b squared. B is minus 8 minus 8 squared minus 4 times a is 1 times c is 41 over 2 times a is 1. Okay, so let's simplify that a little bit. That's equal to, I wrote this formula wrong, x1, x2 is equal to. Let's not forget that. You can lose stupid marks like that if you don't get your formatting right. Okay, so let's simplify this a little bit. Minus times minus is 8 plus or minus the square root of 8 squared is, or minus 8 squared is, pop it into a calculator if you don't know, but the answer is 64. Minus 4 times 41 is 164 over 2, which is equal to 8 plus or minus the square root of negative 100 over 2. Okay, let's carry on over here. So 8 over 2 is 4. Plus or minus the square root of minus 100 over 2, which is 4 plus or minus the square root. So now we start factorizing this, which is minus 1 times 100 over 2. Don't forget that. 4 plus or minus square root of minus 1 square root of 100 over 2, which is 4 plus or minus the square root of minus 1 is j. The square root of 100 is 10 over 2, which is 4 plus or minus j5. Okay, and if we want to write it out, once again I forgot to carry my x1 comma 2 equals x1 comma 2 equals x1 2 equals. This should be fine as a final answer, but you can also write it as x equals 4 plus j5 or x equals 4 minus j5. And there you go. There you have your roots. Done and dusted. And that is question 6 out of the way. Okay. Let's open, I think I'm going to do one more for this video, and then we'll revisit, we'll make another video with some more questions here because we're already hitting the 45-minute mark. So, okay, here's one that's a little bit more interesting. Question 7. And this question says, solve for x and y. X and y. And they tell you that x plus yi is equal to 3 plus 5i times 2 minus 7i, and remember I is just a complex number again, it's not a variable. 1 minus 3i. Okay? So once again, what they're actually trying to get you to do here is they're asking you, by saying solve for x and y, all they're saying is take this equation, get it into the form x plus yi, and then you will know what x and y are. Or, said otherwise, get this equation into the general form a plus jb. And you know what a is and b is, and that is x and y. So, how are we going to do this? So this is multiplication and division. It's going to be very difficult to do it in rectangular form. It's going to be a bit of a mission. So let's do this one. So what we're going to do is convert all of these numbers. So we're going to take this, convert to polar form, do the calculation, and then convert back to rectangular. Because once again, multiplication and division is far easier in polar form. And I'm going to run through the conversion to polar form very quickly. We're going to do it for each of these numbers. So for that one, let me highlight them a little bit. Oops. Okay, so we're going to do it for that one, and that number. Then we're going to write it out again, do the calculation, and then convert back to rectangular. So, how do we convert a rectangular, a number in rectangular form into polar form? Well, rectangular form is a plus jb, and polar form is r angle theta. And we know that r is equal to the square root of a squared plus b squared, and theta is equal to arctan of b over a. So, for the first number, we've got r is equal to, I'm going to call it r1, is equal to 3 squared, square root of 3 squared plus 5 squared. Theta equals tan inverse of 5 over 3. Okay. Then for the next one, we've got r2 is equal to the square root of 2 squared plus 7 squared. It's actually plus minus 7 squared. You see there, minus 7. Okay, and theta equals tan inverse of b over a for the second number is minus 7 over 2. Minus 7 over 2. Then for our third number, we've got r3 is equal to the square root of 1 squared plus minus 3 squared. Theta equals tan inverse of minus 3 over 1. Okay? Now we're just going to quickly calculate all of those, and then we will have them, we'll have our numbers written out in polar form. So we're going to have Z1 equals R1 angle theta 1, Z2 equals R2 angle theta 2, and Z3 equals R3 angle theta 3. Okay, so I'm just going to quickly do those on my calculator. I'm not going to do all of that work over there. So 3 plus 5i equals, and we're going to convert that to polar form, which is, and you feel free to check this for yourself by calculating these and check that I'm doing everything correctly. We've got root 34 angle 59.04. Okay, then let's do our second number, and that number is 2 minus 7i is equal to, in polar form, that gives 7,28 angle negative 74, 3,05, and our last number that second number looks really bad. It's a 7,28. Right. And for our last number, we have 1 minus 3i, and then convert it to polar form. That gives us 3.16 angle negative 71,57. Okay, so now we can write out this original equation. X plus yi is equal to z1 times z2 over z3. So root 34, let me do that in color for you. Root 34 angle 59,04, okay, multiplied by our second number, which is 7,28 angle minus 74,05, okay, and our last number there is Z3, which is 3,16 angle minus 71,57. Okay. Now, once again, I'm sure you're sick of hearing this guy's name. It's time to do some De Moivre. And before we do that, what I'm going to do is just erase here on the side. So I'm going to I'll erase this top piece so that I can write out De Moivre's theorems for you again. Just to make sure you've got them. De Moivre says that, okay, R1 angle theta 1 times R2 angle theta 2 is equal to R1 R2 angle theta 1 plus theta 2, running out of space there. And we've also got division here, so we need to know that R1 angle theta 1 over R2 angle theta 2 is equal to R1 over R2 angle theta 1 minus theta 2. Easy stuff. So first let's do the multiplication at the top, and then once we've got an answer for that, we do the division, and then we're going to just convert back to rectangular form. Okay, so according to the first law, we multiply R1 and R2, so that is 7,28 root 34 angle, and then what do? We add the angles. So 59,04 minus 74,05, that is over 3,16 angle negative 71,57. Sorry, my handwriting on this thing is not great. Alright, so let's simplify this top piece and then we'll do our division. So 7.28 times the square root of 34 is equal to 42,45 angle, then 59,04 minus 74.05 is, so the angle is minus 15,01 degrees, over 3,16 angle negative 71,57. Okay, and then according to De Moivre's second law over here, when you're doing division, we get R1 over R2, so 42,45 over 3,16 angle theta 1 minus theta 2, which is minus 15,01 minus negative 71,57. Okay, equals, so let's just do the calculation. 42.45 divided by 3.16 is 13,4 15.43 angle. Let's do that subtraction there. Minus 15.01, and here we've got minus times a minus, so plus 71.57 is 56.56 degrees. Okay, and that is x plus y I equals. Okay, so now we've got our final answer, but you'll note it's in polar form. But our left-hand side here is in rectangular form. So now we need to go polar form, r angle theta, to a plus jb form. Okay, how do we do that? We say a is equal to r cos theta, b is equal to r sine theta. So here we have a is equal to 13,43, which is r, cos of theta, which is 56,56 degrees, and b is equal to, sorry about that, okay, just got to silence my phone here. Okay, and b is equal to r sine theta, which is 13,43 sine of 56,56. Easy stuff. So we're going to pop that into our calculator, and we're going to get a equals 13.43 cos of 56.56 is 7,4, and b is 13.43 sine of 56,56, which is equal to 11,21. Okay, and we've got a and b. So now we know that x plus y I is equal to a, which is 7,4, plus j 11,21, or written differently, 7,4 plus 11,21i. So if you compare the left hand side, you've got x plus y I. So now you can see that, remember the question asked solve for x and y. So now we know that x equals 7,4 and y equals 11,21. And that's it. That's the end of the problem and the end of the video. Thank you very much for watching. I'll see you soon. Cheers.